Students, so we are solving standard 12 physics numericals. Okay. An infinite line charge produces a field of 9 into 10 raised to 4 Newton per coulomb at a distance of 4 centimeter from it. Calculate linear charge density. So how we write linear charge density? It is lambda, correct? So whatever is given you have to write first. Field is given, electric field value is given, E is equal to 9 into 10 raised to 4. Then distance is given 4 centimeter, which you can write 4 into 10 raised to minus 2 meter. Okay, you have to calculate the linear charge density. So here electric field is given, so you have to use the electric field formula in terms of linear charge density, that is E is equal to lambda upon 2 pi epsilon naught r. Correct? So we are given the value of 1 upon 4 pi epsilon naught. That is 9 into 10 raised to 9 Newton meter square per coulomb square. Okay. This is given at the starting of the paper. They give this value. That is the constant. Okay. So E in terms of lambda. So lambda we have to find, right? So I'll write E into 2 pi. Okay, I have to convert this to pi epsilon naught because we want to use 1 upon 4 pi epsilon naught. So I'll multiply by 2 in the numerator and 2 in the denominator. So this will become 4 pi epsilon naught r. Okay. So this value 1 upon 4 pi epsilon naught value you have to multiply here 9 into 10 raised to 9. Okay. Now I can write lambda is equal to E into R upon R upon 2 and this 10 raised to 9 is 9 into 10 raised to 4. R is 4 into 10 raised to minus 2. 2 into 9 into 10 raised to 9. Okay. So 2 into 10 raised to 4 minus 2 minus 9. 11 minus 4, 7. Okay. So this is linear charge density. Linear charge density is given by Q upon L. Correct. That is coulomb per meter. So this is coulomb per meter. Okay. Next question. An uniformly charged conducting sphere 2.4 meter in diameter has a surface charge density of 80 microcoulomb per meter square. Okay, you have to calculate the charge on the sphere and total electric flux passing through the sphere. Okay. So what is given? A sphere is there with a diameter 2.4 meters. So its radius will be what? Diameter divided by 2. So it is 1.2 meter. Okay. Now surface charge density is given sigma 80 microcoulomb per meter square. Micro means 80 into 10 raised to minus 6 coulomb per meter square. Okay. So how we write surface charge density? Surface charge density is given by total charge upon the area. Correct? So area of the surface area of sphere is 4 pi r square. Okay. So we want charge, right? Q is equal to sigma into A. So sigma is our 80 into 10 raised to minus 6. Area is 4 pi r square. 1.2 into 1.2. Okay, so 80 into 10 raised to minus 6 into 4 into 22 by 7. This will be 12 square, which is 144. So 1.44. Okay. So I'll take 8 into this. I'll take with this. Okay. This will be 88. This is 144. Okay. So 144 means I'm removing the point. So this will be upon 100. Then this 10 I have removed. So 10 raised to minus 6 plus 1. And also 7 is there. Okay. 144 on 7 into 10 raised to minus 5, and this will be minus 2. Okay. So this we have to calculate. So after calculation you will get this. Okay, you can shift this point. 1, 2, 3, 4, 5, 5 means minus 2. Okay. Coulomb. Second, we have to calculate the total electric flux passing through the sphere. Okay. So electric flux is given by phi is equal to q upon epsilon naught. Okay. So epsilon naught value is given. Phi q is this. So I'll write it as 0.144 into 10 raised to minus 2 upon 8.854 into 10 raised to minus 12. Okay. So I'll remove the points. So after point, 3 numbers are there. Here also 3 numbers. So I can directly write this 144 upon 8854. This will be 10 raised to minus 2 plus 12. Okay. So I have to divide this. So I'm getting 0.016 into 10 raised to 11. So this is Newton per coulomb per meter square. Okay. Next question. A 3 ohm wire is supposed to be made from a metal having specific resistance of 1.6 into 10 raised to minus 8 meter and length 400 centimeter. Calculate radius of the wire. Okay. So how we write radius in terms of specific resistance? First we'll write what is given. Okay. Resistance is given 3 ohm. Then specific resistance, that is rho, 1.6 into 10 raised to minus 8 meter. Then length is given 400 centimeter. So convert it to meter. Okay, we have to find the radius. Okay, so how we write this? R is equal to rho L upon A. Okay, so we have to find the radius. So whenever the wire is given, we write area as pi r square. Okay, so area we can write it as pi r square. Okay, So we want radius, right? R square, I'll write this side, R into pi. Rho is 1.6 into 10 raised to minus 8. Length is 400 into 10 raised to minus 2 upon R is 3. This is 22 by 7. Okay. Or we can write 3.14. 22 by 7. Okay. So when I take root, okay, this is 1.6. I can write it as 16 divided by 10. Then this is 400. Okay. 10 raised to minus 8 minus 2 into 7. Okay. So this root of 16 is 4. Root of 400 is 20. Correct? Then 10 raised to minus 8 minus 2. So it will be minus 10. And this one is there that I will keep as it is. Minus 10. So this I can write it as 10 raised to minus 10 raised to half. Correct? So it gets multiplied with this 10. So 2 ones are 2, 2 fives are 10 raised to minus 5. Okay. Now everything is in 7 upon 22 into 3 into 10. These things are in under root. Okay, so I can write this as 66 dividing 7. Ones are 0, 6 are 0.106 into 10 raised to minus 1. Like this it will be. Okay, this is our radius. So we can write this as 80 into 10 raised to minus 5. We can remove this 106 divided by 1000. So I can write it as 10 raised to 3 minus 3 minus 1, 10 raised to minus 4. This also comes outside by dividing by root 2, that is 1 by 2. So minus 2. So this will be minus 80 root 106 into 10 raised to minus 7 meter. Okay. Next question. A bar magnet of magnetic moment 1.5 joules per Tesla lies aligned with the direction of a uniform magnetic field of 0.22 Tesla. What is the amount of work done by an external magnetic field, external torque to turn the magnet so as to align its magnetic moment normal to the field direction and opposite to field direction? Okay. So what is given here? Bar magnet of magnetic moment is given M. 1.5 joules per Tesla. Okay. Then a magnetic field is given B. Okay. We have to find the work done. How we write work done? Minus MB cos theta, right? But here they have given two conditions. That is, first is magnet is moved normal to the field direction. Normal means what? If suppose it is in the first it was at 0 degree, okay, Normal means it is perpendicular. It is moved perpendicular. Okay. So we are moving this from, that is theta 1 is our 0 degree to theta 2 90 degree. Okay. And opposite to the field direction means we are moving this to this direction. That is, if it was like this earlier, then I am moving it to this opposite. Okay. So theta 1 is, this is from 0 to 180. Okay. So then our work done is given by minus mb cos theta 2 minus cos theta 1. Okay. M minus b 0.22 into cos 90 minus cos 0. 5 into 0.22 cos 90. So you have to by heart the values 0, 1, 0, 1, 0. Cos 90 is 0. Cos 0 is 1. Okay. So minus into minus it becomes plus 1. So this is 1.5 into 0.22. 15 into 22. 330 and after 3 points 0.33 joules. Okay. This was from 0 to 90. Now we are moving from 0 to 180. Same formula. 1.5 into 0.22 cos 180 minus cos 0. Cos 180 is opposite of 0. Okay. So whenever you have a 1 in 0, you will have a minus 1 in 180. So this we got as 0.33. Cos 180 is minus 1. This is minus 1. 1. This is 1 and this is minus 1. So it becomes minus 2. So 0.66 joules.